compound is composed of 52.14% carbon, 13.3% hydrogen, and 34.73 oxygen by mass. Find the empirical formula. Convert the percentage of each element into mass. First, we have 52.14 grams of carbon, 13.13 grams of hydrogen, and 34.73 grams of oxygen. Multiply it by 1 and divide it into its atomic mass. For carbon, we will have 12.01 grams of carbon. For hydrogen, multiply it by 1 and divide it into 1.008 grams of hydrogen. For oxygen, you will have to divide it into 16.16 grams of oxygen. Get the quotient of each equation. For carbon, you will have 4.34 moles. For hydrogen, you will have 13.02 moles. For oxygen, you will have 2.171 moles. Divide each equation into the smallest quotient. Since the smallest quotient is 2.171, we will use that. 4.34 divided by 2171, 13.026 divided by 2171, and 2170 divided by 2171. For carbon, we will have 2. For hydrogen, we will have 6. We will have 1. So the ratio is 2:6:1. So the empirical formula is C2H6NO. That's the answer. For the second problem, PVC is used to make plastic drain pipes. When analyzed, it is found to contain 4.84% of hydrogen, 38.4% of carbon, and 56.7% of chlorine. What is the empirical formula for this compound? Convert the percentage of each element into mass. First, we'll have 4.84 grams of hydrogen, 38.4 grams of carbon, and 56.7 grams of chlorine. Multiply it into 1 mole and divide it into its atomic mass. For hydrogen, the atomic mass of hydrogen is 1. The atomic mass for carbon is 12. The atomic mass for chlorine is 35.5. Cancel the units. .84 grams of hydrogen times 1 mole divided by 1 grams of hydrogen is equals to 4.8. For carbon, you'll have 2.2, and for chlorine, you'll have 1.6. Divide each quotient into the smallest quotient of your formula. For hydrogen, you'll have 3 hydrogen. For carbon, you'll have 2. And for chlorine, you'll have 1. Since we obtained the smallest ratio by dividing the lowest number, the ratio is 3:2:1. So, our empirical formula is H3C2Cl. And that will be the answer for this problem. Determine the empirical formula of compound, which is 54.09% of carbon, 43.18% of oxygen, and 2.73 of hydrogen. The first step is to convert each element into mass. For 54.9 grams of calcium, 43.18 grams of oxygen, and 2.73 grams of hydrogen. Multiply it by 1 mole and divide it into its atomic mass. For calcium, we have 40 grams of calcium. For oxygen, we'll have 1 mole divided by 16 grams of oxygen, and for hydrogen, we'll have 1 mole divided by 1 mole, 1 grams of hydrogen. Cancel the units. 54.9 grams times 1 divided by 40 grams of calcium is equals to 1.4 moles of calcium. 43.18 times 1 divided by 16 is 2.7 moles of oxygen. 27.3 grams of hydrogen times 1 mole divided by 1 grams of hydrogen is equals to 2.73 moles of hydrogen, divided into its smallest number of moles. Since the smallest number is 1.4, we'll use that. 1.4, 2.73 divided by 1.4 is equals to 2. 2.7 divided by 1.4 is equals to 2, and for the calcium, we'll get 1. We'll have 1. So the ratio is 2:6:1. So the empirical formula is C2H6NO1. So the ratio for this equation is 1:2:2. So the empirical formula is CaO2H2.